What is a secondary carbon? What is a tertiary carbon? What is a quaternary carbon? What is a primary carbon? So these things can be answered if you know the degree of carbon. So what is the degree of carbon? Degree of carbon is understood like this. I'll explain it to you. If a particular carbon, this carbon we I'm talking about, it is connected to one another carbon, this is known as 1 degree carbon. If another carbon is connected to two carbons, then this carbon is known as 2 degree carbon. If I connect this carbon through three carbons, right? So now this carbon is known as 3 degree carbon. So basically degree of a carbon is the number of carbon atoms a particular carbon is connected to. So this is a 1 degree carbon or primary carbon. This is a 2 degree carbon or secondary carbon. This is a 3 degree carbon or tertiary carbon, right? Now if I want to tell you that we have a quaternary carbon as well, I will do like this. I will connect one carbon with four other carbons. Now this carbon is connected to this carbon 1, 2, 3, 4. So this carbon is known as 4 degree carbon. So carbon connected to how many other carbons represents the degree of carbon. So we have a primary degree, secondary degree carbon, tertiary degree carbon, and we have a quaternary or 4 degree carbon. So the number of carbon atoms a particular carbon is connected to is known as the degree of that carbon. 1 degree carbon is called primary carbon, 2 degree carbon is called secondary carbon, 3 degree carbon is known as tertiary carbon, and 4 degree is quaternary carbon. And along with that, I'll give you a bonus tip. Sometimes you might get questions on degree of hydrogen. So degree of hydrogen e- equals to degree of carbon equals to degree of carbon to which it is attached. Degree of hydrogen equals to degree of carbon to which it is attached. So if a hydrogen is attached to 1 degree carbon, it will be called as 1 degree hydrogen. For example, if I connect hydrogen here, so these hydrogens in white are called as 1 degree hydrogen. These are 1 degree hydrogens. If I connect hydrogen on 2 degree carbon, then these hydrogens are known as 2 degree hydrogens. If I connect hydrogen, if it is already connected over here, so this carbon is 3 degrees, so hydrogen attached to that carbon is also 3 degree hydrogen. So this is a primary hydrogens, these are secondary hydrogens, this is a tertiary hydrogen. And what about quaternary hydrogen? Can we connect any hydrogen to a 4 degree carbon? I think you will say no, not at all, because a carbon can maximum form 4 bonds. So this carbon already has 4 bonds, so we cannot connect a hydrogen to a 4 degree carbon. So we can never have 4 degree hydrogen is something which is not possible. So 4 degree hydrogens do not exist. If somebody is saying that count 4 degree hydrogens, that means he is making joke of you. So just answer that number of 4 degree hydrogen is 0. 4 degree hydrogen can never be a possibility. Now we have few rules out here. As you know, longest carbon chain is selected as the main chain. Then what is the next step? You have to do the numbering of the chain. So while numbering the chain, just remember the priority order. Just remember the priority order. What is the priority in numbering? While numbering, priority is functional group. So functional group is given the smallest number. Functional group is given the smallest number. Next come double and triple bond. Next comes side chains. So smallest number is given to functional group. Just imagine functional group to be the hero of the movie. So it is the hero of the movie. So it has to be given the smallest number in the chain. Then double and triple bonds are side heroes. Alright, and side chains, as the name says, these are something to be kept on the sides. So smallest number, if all the three is present, give the smallest to functional group. If functional group is not present, then give smallest number to double or triple bond. If it is not present, give the smallest number to side chain. And next, If you have more than two double bonds, triple bonds, then in this just follow lowest locant rule. Lowest locant rule. And again, if you do not have double triple bonds and you have multiple side chains, then again you have to follow lowest locant rule. So from whichever side you get lowest positions, follow that side of numbering. All right. Next, what do we have? When the positions are held up, for example, on the second position, you have a bromine attached. On from the left you come, and from the right you come, you have chlorine attached. As you know, bromine comes first, so give smallest number to the bromo or bromine. All right. So when positions are not different, when from the left you get second position bromine, from the right you get second position chlorine, then give the priority to the alphabet which is coming first. So the numbering will start from the bromine side. Alright. So alphabetical is the tiebreaker. Alphabetical point is tiebreaker, that you are held up from both sides, same numbering is coming, then decide whichever alphabetically comes first, start numbering from that side. Alright. Next few more points are there which are already mentioned, and we have to just remember that if something is repeating, just say, if 2 times something is repeating, say di. If 3 times something is repeating, say tri. 4 times tetra. And for repetition of complex side chains, you have to remember we use bis for 2 times repetition, for 3 times repetition use tris, for 4 times tetrakis, 5 times pentakis. These are few representations for complex side chains. So this is it for now.